I urge you to pay close attention to this example. It's very important. We're asked to find the limit as t approaches 0 of sine squared of 3t over t squared. And this is going to involve a trick. So just watch very closely. You'll be able to use this trick on several of your exercises, your homework exercises. Solution step 1. Step 1. Let's rewrite this limit. So we're going to make some modifications to the way that the limit is stated, the function part. And there'll be legal modifications. First, we're going to say that the original limit itself is equal to the limit as t approaches 0 of, okay, bust up this sign. We've got sine 3t over t times sine 3t over t. See, that's the same as sine squared 3t over t squared. We just broke it apart. And now we'll distribute the limit across multiplication, which is absolutely legitimate. That's equal to limit of sine 3t over t times limit sine 3t over t. Now, this looks a little familiar from what we saw earlier. We go, we know that the limit as h approaches 0, the limit as h approaches 0 of sine h over h is going to be equal to 1. We showed that in a previous video. So we're going to use that. We're going to try to rewrite each of the limits above to get the form of limit h approaches 0 of sine h over h so we can replace it with the 1. So that's the goal. That's how we're going to use this trick. So what we have up here is a limit of sine 3t over t times the limit of sine 3t over t. This is as t approaches 0. So we're going to rewrite that by multiplying each of the factors by 1. 3 over 3 times the first limit factor times 3 over 3 times the second limit factor. That doesn't change the value, just multiplying each of them by 1. But now we're going to take the denominator 3 and pull it inside the limit and put it in the denominator of the function. Now that's legitimate because remember, constant numbers can move inside and outside of limits without any problem. So we'll pull that 3 in the denominator inside the function, inside the limit. Now, look what we have. We've got the limit of 3t over t in both of those cases. So now we'd go to step 2. We are going to use the limit of, as h approaches 0, of sine h over h equals 1. We're going to use it. We're going to make a substitution. All right, now you have to follow along here. Make sure this is acceptable to you. Let h equal 3 times t. Notice that as t gets closer to 0, 3 times t will also get closer to 0. Thus, as t gets closer to 0, h, which is 3t, will get closer to 0. So we can make the following substitution with that argument. Our statement above step 2 is equal to 3 times 3, if we bring both of the 3's out to the front, 3 times the limit as h approaches 0 of sine h over h, because we let h equal 3t. And we know that as t went to 0, h would go to 0, so we can write it this way, times limit as h approaches 0 of sine h over h. So that's equal to 3 times 1 times 1, applying what we said in step 2. So that's equal to 9. Thus, we've shown that the limit as t approaches 0 of sine squared 3t over t squared, the original limit, is indeed equal to the number 9.